Hello, everyone, and welcome to our webinar, LLMs in Banking, Building Predictive Analytics for Loan Approvals. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is currently being recorded, and you're currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a single store event, heads up that we sponsor regular webinars and events demoing data, AI, and engineering use cases and new technologies. And if you click to the next slide, Akmal, you'll see that the next big thing we're looking forward to is the real-time AI conference that's on October 17th at the Chase Center in San Francisco. And today only, Single Store is sponsoring discount codes for this audience only. You can get your $25 ticket right now. It's usually $199. All you need to do is click the link that you see on your screen, bit.ly/AI conference webinar 25 discount. I'll put that link in the chat in a minute. You can also take a photo of that QR code that you see on your screen or a screenshot of this, and all you'll need to do is enter the code singlestore-25 during checkout, and you'll get access to your $25 ticket. So again, I'll put that in the chat in a moment. And for now, we can leave that up on the screen for a minute and get back to today's topic. FYI, we have fantastic technical experts who are going to be online. We have a good grasp of the technologies that's going to be shared today. We're ready to answer your questions as they come through. So we'll try to get to as many of those as they come through. And I'll also flag a few for the live Q&A, which will be at the end of today's session. Also, we'd love for you to check out and try out today's technology. Akmal, if you jump to the next slide, you'll see that anyone who tries out the technology today will be entered for a chance to win a brand new pair of AirPods Pro. All you need to do is click the link or type in that link that's on your screen, the bit.ly/banking-webinar-raffle. I'll put that in the chat as well, or you can take a photo or a screenshot of that QR code that's on your screen. And all you need to do to be eligible is log into Single Store, which you'll see when you reach that link. You can do a free trial if you're a new user. You can do an existing account if you're already a customer of Single Stores, or an ongoing trial at Single Store. And we will just check the folks who have clicked that link or come in through that link today, and we will announce a winner by the end of today's session. So good luck to you on that. Let me introduce our speaker for today. Akmal Chowdhury is a senior technical evangelist at Single Store. He's got strong technical expertise in big data, machine learning, and AI. He is a prolific author and a regular speaker at our weekly webinars on data and AI. Welcome, Akmal. You now have the floor.
Great. Thank you very much, Matt. And thank you, all of you, for joining wherever you are. Good morning, good afternoon, good evening. So it's just gone 6 p.m. my time here in London. And as some of you may know, we did an event a couple of weeks back focusing very much on stock and ticker data. And I put a small disclaimer up that time. I'd like to put a slightly bigger disclaimer up this time, because I think it's very important when you're dealing with some of the kind of decisions that you would make with loan approval. There needs to be free of bias and adhering to appropriate regulations. Okay, so if I can just read that very briefly. So using LLMs in lending decisions raises ethical and regulatory, if I can say the word, regulatory challenges, including potential bias in model outputs and a lack of transparency in decision-making. It's crucial to work closely with legal and compliance teams to ensure that your predictive analytics approach adheres to all relevant laws and regulations, such as fair lending laws and data privacy regulations. Additionally, consider fairness and bias mitigation techniques to ensure equitable lending practices. Rather important, I think. Especially if you plan to apply some of this LLM technology in this type of application domain. Okay, so I've got a fairly simple agenda, not a great deal in terms of slides. Mostly it's focused around a notebook And I do need to provision some resources, so I'm going to have to do that with you real time. In a moment, we'll take a look at that. Okay, so Matt gave you the link previously, and I'll walk you through the steps for that as well, because I need to do it myself. Let's go. So what do I want to focus on today? As always, you know, time is always against us. There's always far too much to try and cover, but what we'll try and do, and I'll do my very best, is obviously cover the issue of loan data, okay, and how we can manage that with single StoreDB. We'll look at sort of fairly standard existing approaches to how we might do this using building a loan prediction model using logistic regression. Very briefly then, I kind of investigated a few existing tools and technologies out there that I thought might be particularly useful for this kind of application. And in particular, I looked at BERT. Okay, so my experience is there. Well, overall, I don't think it's going to help, but that's one of these things that you find out only through use and trial and error. Okay, but that's fine. Nothing wrong with that. Okay, maybe it will save you time. And then a couple of other tools that I looked at that might be useful, particularly in terms of kind of determining, how these black box models, in terms of what the emphasis there is, how they are actually delivering the results and get some insights into that. So looking at something called Sharp, which I came across very recently, and also Lime, which I think has been around for a little while. Both tools very helpful in providing some useful insights into the data. Now, as far as LLMs are concerned, it's very difficult and challenging, I think, to find a way to be able to utilize what essentially is a very sort of semantic based technology in terms of question and answer and sentences and asking information about the world at large, trained on billions of data points and parameters, how that might be useful given all the points that we raised in the disclaimer. However, you don't have to create embeddings. You could very easily use this LangChain SQL agent, which I really like because I find it, kind of, in a sense, it allows you to try out the abilities of the LLM without having to create a lot of overhead around it in terms of embeddings in particular. So that's very useful. So trying and applying that problem to this loan approval, I was quite surprised that both of the data points that I gave it, one that I knew where the loan had been approved and the other one where I knew that the loan had not been approved, it actually got the answer correct in both cases. Now, would I use it for loan application and loan approvals more generally? Hard to say. With only two data points, and admittedly it got 100% of the answers correct, I would need to do further investigation. And I think particularly with LLMs, because they tend to be rather opaque, it's kind of hard to know exactly how they made the decision process. Although with the LangChain SQL agent, for example, you can ask it to tell you how it arrived at a decision, which it will show you what it actually interrogated and the steps that it took, but it doesn't give you the detailed insights that some of these tools, for example, might do, particularly if you're dealing with sort of existing approaches. Time permitting, if we have the opportunity, and I suspect we won't because I always go on too much, is I thought, well, how about if we use something like an AutoML? Would that be a good kind of halfway house in the sense that it clearly there are some rules that are built into this technology and it would be able, it should be easier to use. At the same time, it could be very well augmented with something like a large language model as well. I mean, in this particular case, MindsDB is a technology that I've used before. It's somewhat easier to use. Basically, you just feed it the data, you tell it what the target is, and it just goes away, builds a model, and then you can easily interrogate it. So we'll try that if we have time. If not, don't worry. It's not a big deal, not a deal breaker, okay? Couple of points. So yes, Matt will send a link to the recording of this. Yes, there is a GitHub repo, and yes, I will share the notebook that Matt will send the link out with the video, okay? Because there's a couple of things that I need to just finish off and tidy up before I'm happy to share that with you. And so all of the resources and assets will be available in due course. Okay, let's take a look then. Okay, so very briefly then, a couple of words about single store. I won't dwell on this too much. I mean, it is a distributed SQL database system focused very much around in-memory in the past. MemSQL, you may have heard of it. Subsequently developed a columnar store as well to deal with analytics, some min, max, average count, and be able to work at scale. And we see today that, you know, there are a number of distributed SQL database systems. So this is kind of emerged over the last 10 years or so, where prior to that, you know, we've seen several generations, if you like, or waves of database technology, sometimes come, sometimes go. Here I'm thinking in the distant part, late 1980s, early 1990s, when I was doing my research work, you know, the hot technology of the day was object-oriented databases. I think very few of those vendors still exist today. Either they've been bought up, they've gone out of business, or, you know, the technology has kind of passed. You know, it's reached end of life in a sense. More focused around single store DB then, so it can handle both the OLTP and OLAP workloads through this universal storage. Has awesome integrations. I've used Kafka and Spark a lot in the past, and that's both the open source Spark and the open source Kafka, as well as from Confluent and Databricks respectively. It is available on the 3 major cloud platforms in the Western world: AWS, Google Cloud, Microsoft Azure. You can install it on-prem as well. And the link that actually Matt shared with you, if you sign up and create an account, within your account environment, there is actually the ability to get a license that's already created for you in there that you can use to deploy your own up to 4 sort of node cluster, you know, either in your own environment, or you could do it in a virtual environment or in the cloud somewhere if you want to. There's a Docker image as well, which is a great way to test it out, you know, almost zero cost, no risk. And that might be something you might want to think about. So at its heart, this is a question that gets asked a lot. I mean, what is single store DB? Well, it is a relational database system at its heart, but it does support lots of other data types. Okay, so let me just get my arrow here. Okay, so there we go. And so we can do things like geospatial. There is the Lucene full text engine built in, okay, for full text search. If you want, you could do key value. There is JSON support as well, which has been in there actually for some time, but with the advent of single store, the Kai offering, you know, for MongoDB, that is available as well. That's another way that you can work with JSON data. You can do time series as well, and vectors, okay, the last thing here. So the important thing about vectors, and obviously that is very pertinent, very relevant to OpenAI, LLMs, whether you're using open source or proprietary ones, is this ability to store embeddings. Well, keep in mind that single store has actually had support for vectors since 2017. So it's not something we just added today or we added yesterday. And the other important thing about all of these is these are all first class, in the sense that they are not, it's not a layering, it's not you know, some kind of bolt-on or something, but they are all part of the core engine. And that is a significant benefit. Okay, so other things, real-time decisions, AI apps, dynamic experiences, and you can use and plug in lots of third-party tools if you want to, dashboards. There is a SQL editor built in as well, or you could use, say, a MySQL client if you want to interrogate the database and run SQL queries, for example. Okay. Some of the ways that you could interact with single store DB if you want to do machine learning. I mean, here's some examples here. This is not an exhaustive list, okay, but just some of the tools that I've worked with during the 2+ years that I've been here. So I've used in the past things like mlib with Apache Spark and working with single store DB. And our Spark connector supports pushdown. Okay, so that's very useful in that Spark asks the database system to take care of some of the processing where it has more intelligence and more knowledge about the data than Spark does. We've demonstrated some of these other features as well in webinars this year, but today I'll try my best and show you, okay, a little bit on the OpenAI, but that's going to be through the LangChain, and some let me just do this. And there are a series of vector functions as well, as I said, dot product, Euclidean distance, and a whole host of other supporting functions that are available that we've demonstrated, again, when we've worked with embeddings. Okay. All right, then. So a couple of slides on loan approval prediction then. So why think about using a large language model then? Well, analyze large quantities of data from a variety of sources. Probably most banks or lending organizations tend to do this anyway. Things like credit reports, income statements, spending habits. I get my bank regularly sending me offers in terms of, we can give you a loan for X thousand pounds, because we noticed that you've been a good customer for a very long time, you have a good credit rating, and you seem to be able to manage your money very well, and so on. But I think we can utilize more information as well in terms of the LLM being able to dig into more detail and being able to process much larger quantities of data. This is where we get the identify patterns and trends from the customers who has a history of making on-time payments on other loans and has a stable job. Those might be very important factors. And for the third point, here it gets a little bit tricky. I kind of found this discussion, but again, it's one of these things that you have to think very carefully about, given the disclaimer that I mentioned right at the beginning, using other information. Such as social media data. That sounds a little bit tricky to me. You need to be careful there. We've had some issues here in the UK recently about political leaders, having their accounts closed, for example, for various reasons. And it may be down to, the bank not liking that person for some reason or other, simply because of their political views. I don't want to get it's a minefield which I'm not going to go down, but that's a reality and it's in the news, okay? And that's something that we have to think about very carefully. These biases tend to get introduced, and we must be conscious of these and ensure that we treat everybody fairly. That's rather an important point. In terms of the loan approval, then develop predictive scoring models, score loan applicants based on their likelihood of repaying a loan. I think we tend to do that anyway. Or banking organizations tend to do that anyway. But again, where the LLM could help is in terms of mining and sifting through much larger quantities of data. And then perhaps using additional techniques beyond just statistical techniques that we might have. That could be very useful as well in terms of identifying fraudulent loan applications. Fraud seems to be still a big problem. For those of you who attended the webinar that Matt and I did earlier this year, I think right at the start of the year, we looked at how an LLM could help with fraud detection. And at that time, I was not convinced that it could be very useful. Existing techniques seem to work much better. But again, it's this case of, the LLM for the semantic type of search, and being able to Q&A, analyzing sentences, it's great. It isn't necessarily great at looking at large quantities of numerical values, for example, or being able to detect particular patterns in that. So I found at the time. Things may have changed. I'll have to go back and revisit that and see if my view has changed on that. Where it could help, though, is again, in terms of improving the customer experience. Okay, give customers more personalized recommendations for loan products and services. The ability to develop these kind of chatbots. Very, very easy and very simple. As a company, we've done it ourselves, called Squirrel. Okay, so it focuses very much around our product, using information in our documentation, blog posts, forums, and so on. So it's trained specifically on that data, and then you can interrogate that and ask it questions about that, and it will give you answers based upon that. Very similarly, you could do this for loan approval as well. And give the customer an opportunity to ask these type of questions and get back meaningful answers based upon the kind of things that they're interested in doing. I think the challenges then, specifically for small and medium businesses, I think this is going to be a problem. Can be complex and expensive to develop and deploy. If you are not Facebook, you are not Google, you are not OpenAI or some other large organization that who has the resources and the money to be able to develop these kind of large language models, then I think it's going to be quite challenging for you. Bias may be introduced, inaccurate predictions. You see this all the time in terms of hallucinations, for example. Okay, so there's an issue there. That happens again. And again, this problem of requiring lots of data to train. And if you simply are in a position that you are not a very large organization, being able to spend the time and resources to build your own, I think is going to be a very big problem for you and a big challenge. Doesn't necessarily mean you can't do it. It's simply, it may not be worth it, okay? Because the amount of time and effort you put into it, you may not get the appropriate payback. So that's one of the things to think about. Okay, now let's go straight to the demos then. Okay, so let me minimize this a moment and let me make sure that I am sharing the correct window with you. Okay, so you're still seeing my Google Chrome. That's great. That's absolutely fine. So what I need to do, and again, Matt, keep me straight, please. So if I'm talking about something and you can't see it, please do let me know. So let me just terminate this, okay? And we'll just reprovision this and start from scratch. So I'll show you the steps that we need to get here, okay? And just clear all of this and remove it. There we go. We start off with a clean slate, okay? So the link that Matt showed you, and if you, let me just check. I think it's in the, Matt, have you posted the link for the AirPods in the?
Yes, I have. I posted the raffle link for everyone.
Oh, brilliant. Let me just get that then. Let me copy. I see it. My apologies. That's it. That is what I was looking for. Okay, brilliant. Just minimize this. Right. So the raffle link that Matt sent you, it will take you to this page. And this is the sign up page for the cloud environment. So literally in about 2 minutes of your time, either use you can use Google, or you can use Microsoft, or you can put in your first name, last name, and email address and do it that way. You can sign up for an account. Comes with $600 worth of free usage. And as I mentioned before, and if you're a regular and you attend these events, you know that my opinion on this, well, if you're cautious and use these resources well, they can last a long time. So I joined over 2 years ago. At that time, the company was providing $500 worth of credits. I still have credits today, okay? So the amount of credits that you burn, if you want to run something at small scale, just for testing, and then as long as you shut down the resources when you're not using them, you can easily make them last a long time. That can be great in terms of just getting some experience with the technology. So once you've signed up, you will come to something that looks like this. Okay, let me just go to the homepage. Okay, this is the homepage, and then you'll see that there's a couple of things that you can do. There's a left nav here. Let me again pick this over here on the left-hand side. Okay, and one of the things that you'll notice over here is you've got something called group. Okay, so just click on this, and I'll run this through this with you. You just saw me a few moments ago. Just shut that down. So over here, you can see I still have nearly 200 credits available. So, as I said, burn through this carefully, and it will last quite a long time. So call the workspace whatever you want. I'll leave it at group 1. And today we'll use the AWS platform, okay, in terms of the environment. And as far as the region is concerned, well, I suppose the best thing for me to do is see if I can get onto London. Let's try that. Okay, there's a few other things here that might be unique to my environment, but essentially that's all you need there. And then all you need to do then just at the bottom here is click next. There we go. So I mentioned single store Kai, one of the buttons that you have that you can actually enable that. That's not on every region, okay, but this one there is. That is if you want to get a little bit of experience with this. I'll just enable it for now. Okay, and as you can see at the top here, there is the opportunity to adjust the size of the environment here. Okay, so currently it will burn through 0.28 credits per hour. This is the smallest size, which is an S00. If I just have a look here, you can see that, well, if you are an enterprise customer, let's see, it goes all the way up to S384, which is over 3,000 virtual CPUs, 24 terabytes of RAM, and that goes through a hefty 432 credits per hour. So I wouldn't even be able to afford that with what I've got left, but this is fine. You know, you've got enough resources there, and we just hit create workspace at the bottom there. Okay, that's all you need to do. Okay, and so within this environment, we have this separation of storage and compute, okay, which is rather handy. And so give that a few minutes, okay? So once, oh, what's happened? Did I not do that properly? Let me just do that again. There we go. And you'll see here, it's provisioning that. Okay, here you can see in the middle. Okay, so it takes a couple of minutes to do so. And so we'll come back to this in a few moments, okay, once it's ready, and be able to make some use of that. It'll take a couple of minutes to do that. Meantime, what we can do is, if you, again, look in the left nav, can you see, let me draw your attention to that using my arrow. There is this thing called notebooks here, marked as preview. So if you select this, you can see that I've got a few here already, but you can create a new one, okay, at the top here, simply by selecting this, new notebook, or you can import from file. And so when we share the notebook for this session with you, you can just use the import from file option here. It will load it in, and then you'll be able to run it. And then you have the choice of two sort of places where you can put it. You can either put it into a sort of a personal area or a shared area. Shared area is useful if you're working as part of a team and you want to be able to give them the link to that. You know, they might be part of your organization, for example. So that's a great way to be able to share the resources. So in this particular case, I'm just running this on this environment here. Okay. So just give that a moment. There we are. Okay, so if we take a look at this, and let me just zoom in a little bit. Okay, let's have a look. It's made it slightly bigger. There we go. Okay, so building predictive analytics for loan approvals. Okay, so very straightforward. So I'll walk through this, okay, because we're almost at 1:30. So whilst the workspace is still provisioning, let's go through the parts that we don't need the workspace for. So this is just setting up some libraries here. So standard stuff, LangChain, OpenAI, Pandas, scikit-learn, and so on, and Seaborn for visualization. Transformers, okay, this is where the BERT comes in. And then one of the things I noticed that as part of the libraries here, there was something that actually needed a particular version of NumPy. So I just basically uninstalled the older version or whatever version was currently there, if it was slightly higher, and then make sure that I loaded in the specific version here, which was 1.25. Again, a few things here, just some imports, scikit-learn pre-processing, and Pandas, NumPy, Seaborn, etc. This is the data that's being loaded. So I'm just getting this from a Google Drive. One challenge that I faced was actually finding suitable loan approval data. There are a few places, I mean, Kaggle's an obvious one to go to, but beyond that, there's not actually an awful lot of public domain loan type data that you could readily use. This was just one particular data set that I thought was okay. I mean, it's sufficient for the purposes of just demonstration. Obviously, you may have access to data within your organizations that's much more representative of the kind of business that your company does, but that's fine. Okay, so that's been loaded in. And again, just taking a look at this. So it's got some very standard sort of things, your gender, your marital status, whether you have any dependents and the number of dependents there, what's the level of your education, whether you're self-employed, your income, your co-applicant income, the actual loan amount that you want, the loan term, how much sort of time period you want that for, and when you're going to repay it, whether you've got any credit history, the property area, rural, urban, or semi-urban, and then the loan status, okay? Whether you were actually approved for this, Y, or you are not, N. And within this, there are actually quite a few rows that have a fair bit of sort of missing data. So one of the things that we can do is just take a look at this. We can see there's roughly 600 rows here. For most of them, some of them, I think this one here, for example, we only got 577, and this one here is only 549. So the standard thing to do is just do a bit of pre-processing. Basically, you could impute the values for stuff that's missing. I just simply decided to drop them. Okay, just drop these rows in place. And as you can see, that shrinks the data down to quite a bit. You know, you're losing almost 100 there entries. So it's just over 500 now, 505, but it's all consistent and the same. All right, then. So for model building, just drop the loan ID column because that doesn't serve any purpose for us. It's not going to be useful for us. And then loan status is the target that we're aiming for. And then we just, you know, separate the features in the target variable there into these two parts there. Okay, so the loan status. For the visualization, then, just take a look at the numeric only values. Okay, so just draw a quick heat map just to take a look at, see what we can spot here that might be of interest. Well, an obvious one is the fact that the loan amount here is very much dependent on the applicant's income, this column here. Okay, so if we take a look at the this thing here, you can see there's a very strong sort of relationship between that and that, which is probably what you'd expect. I mean, generally, if you don't have the means to be able to pay back the loan, chances are you're not going to get the loan approved anyway, all right? So the bank lender is going to look at your you know, the income, that disposable income that you have after everything else, and then see what is the actual, you know, how much you want to borrow, and then see if that's going to be something that you'll be able to meet those requirements. One good thing, you can do other things as well, just creating simple sort of scatter plot. Okay, so there's a very strong relationship in terms of loan amount and applicant income. So you can see that the income for a lot of these applicants fairly low, and I think these are in US dollars. So there we can see that it's fairly grouped. You know, we're looking, the maximum there is around about 20,000, and then the actual loan amounts are fairly small as well. I noticed very few outliers there. You can see, you know, there are a couple, but the vast majority are concentrated in sort of one area. So people's income is fairly low, relatively here, and the amount that they want to borrow as well is fairly low. There's a great way to take a look at some of these other, you know, drawing this kind of pair plot. You get to see a little bit more insight into some of the data, and again, it's very similar sort of pattern. So this one here, for example, is the one we were just looking at above, but rather squished down into a slightly smaller area there. So again, just looking for any trends, anything interesting that we might observe that would show us some particular pattern. And I don't see anything particularly strong. I mean, it seems to be fairly well distributed overall. Okay. And then I think there's a couple of ways that you can handle this data. I mean, there are categorical columns that we need to deal with. How do we do that? Well, I chose one-hot encoding, and basically for most of them where there's a binary option, there's a choice. You know, for example, for the credit rating, it's either got a 1 or a 0. But for dependents, you've got multiple possibilities, and the property area, you've got 3 possibilities. So here, just creating a one-hot encoding, and we're keeping all the values in the sense that we might be very interested to look at the fact that someone has a number of dependents. You know, with this, we could we could remove values that we felt were so superfluous, if you like, because with one hot encoding, it's either 0 or 1. We would obviously want to keep the 1, but we might want to keep more than 1 0 just to see if there's some influence in the model overall. Then here, simply taking logistic regression, okay, doing our train test split. So 30% for testing, 70% for training, and just using logistic regression because we've got 2 possible outcomes. Either you get a loan or you don't get a loan. And that seems to be a very sensible approach. Other models, other approaches, of course, may be worth investigating. And I have seen, a number of different algorithms being used here as well. But this is fine for just this purpose here. Taking a look then in terms of the visualization of the feature importance, then what's the outstanding thing that we see here, which, stands out like a mile? Well, it happens to be the credit history. That seems to be rather important here. And the fact that you live in a sort of semi-urban, that seems to be rather important as well. Now, here's where we get slightly more into the bias. Okay, you are married. That seems to be rather important. And your gender seems to be rather important down below here. So again, we are not even talking about LLMs here, but already we see that there is some influence here based upon these particular characteristics that we have in this sort of data set. Okay, just going on a little bit more then, and then just pulling out a particular value here, and then taking a look at the, this is the very first row in the data frame, okay? Just taking a look at sample index 0, and then we can see that the gender happens to be 1, marriage status 1, education 0, self-employed 1, applicant income 7787, and so on. No co-applicant income. Loan amount, again, fairly small. It's only $240 there. Loan amount term, 360. And credit history, yes, seems to be that there is a good credit history there. The dependents. And so we've got the one hot encoding, as I said before, keeping all of these different options here. Okay, the fact that you've got no dependents, you may have 1, 2, or 3, or I think the 3 includes 3 or more. And the different in terms of the property area here as well. So for this particular person, they happen to live in urban. Okay, so here just really picking up the details of the property area, because we're going to use this a little bit later on. And then one of the things that I wanted to look at was BERT. I'd come across this before, and I'd used this a few weeks back for FinBERT, for the FinTech webinar that we did. And so I was curious to see, this is already available and it's been out there for some time. Is there a way that would be possible to utilize this along with sort of traditional techniques that we have already, well tried and trusted techniques in terms of machine learning and data science? And so I took a look at this, and the specific one that I focused on was this one, DistillBERT, which seemed to be fairly low in terms of resource usage, and seems to be, it's well tried and tested, seems to be, gives good performance and good results. And then so I tried to test it on a very simple example. Give it a sentence. The quick brown fox jumped over the lazy, oops, let me get rid of this, the lazy dog. And the one way to use this is to simply mask the word that we want it to fill in for us to create this kind of pipeline, this text, this sentence, if you like. And actually it got it wrong. So its solution was the quick brown dog jumped over the lazy dog. So obviously there was not enough information for it to realize that this is, the word should be fox, that it should be filling in there. So as you can see, by no means is this perfect. Okay, so even here, despite the fact that this is a very well-known phrase, certainly in the Western world, it still didn't quite get that right. And then how would I be able to utilize this in, with the existing modeling that we've just done above? Can we take the loan application summary and the results of the logistic regression and be able to create this sort of text generator as well using BERT to combine the two in a way that would be useful and meaningful. And so this is what I tried to do here, to say, you know, can I utilize these two technologies together to serve a purpose? And once I'd done that and actually produced the summary here, well, the end result was that all it gave me in terms of the extra bit of information was simply add the word area here. So let me just try and do this, okay? That's all I got from it. So, okay, admittedly, there was not a huge amount of effort that I put into this, and maybe my expectation was too great in terms of what I thought it might be able to do for me. But you know, take it or leave it there. You know, it's really up to you. You may find some use for this. In this particular instance, I didn't think that it helped significantly. It didn't add significant value to the overall sort of process that I was trying to accomplish here. Although, in terms of the summary here, this particular person, as far as the model prediction was concerned, the loan was approved. The decision was yes. And if I actually check the value for this within the test data, yes, that is actually the correct decision. And then looking at this to see what are the things that BERT was actually considering when it was looking at that, well, you can see these within the word cloud. Obviously, things like income, credit history, the applicant name, for example, seem to be important, although that's not actually part of the original data set. So you can see a few things here seem to be prominent, whereas some other things that perhaps things like, you know, the property, the urban area were less significant overall. Okay, moving on. So other things that might be useful. Again, this thing, shapely additive explanation. Very useful. I mean, tool rooted in cooperative game theory, systematic approach to explaining the output of machine learning models, enables data scientists and machine learning practitioners to dissect the black box nature of these models by quantifying the contribution of each input feature to individual predictions. So very useful. I learned about it very recently. And so what I thought, well, okay, let me try this and, you know, give it that particular data that we were just looking at above, that particular first row from the that we just extracted earlier on, and then just take a look at what sort of features were sort of prominent there in terms of its decision. So we can visualize this, okay, through this thing called a force plot here. And actually, I think I can click on this, just make it a little bit bigger. So the things that were kind of important, the co-applicant income, the gender, and again, you know, whether you're married or not. So there's obviously, you know, it feels a little bit uncomfortable having to, you know, the fact that that is a factor that would decide this. Obviously, in this particular case, it does seem to have a bearing. The credit history, I would have thought, yes, that's pretty important. The loan amount seems much less significant. The fact that you've got dependents as well, one dependent seems much less significant, and where you live seems much less significant as well. So certainly some things there that seem to be sort of, you know, higher in importance versus others. But that's a kind of a useful way to look at it. And another way that I came across this technology, LIME, as well, local interpretable model agnostic explanations, very similar, gives you the opportunity to kind of just have a look. And it does so for the specific data for that one person that we were looking at. So it shows you, rather than analyzing the entire model, it shows you what are the factors that were significant for that particular you know, data that we were looking at. And here again, you can see loan amount, term, whether you're married or not, co-applicant income, and so on. Those seem to be rather important factors overall here. And again, that could be very useful in terms of kind of understanding, you know, how is this loan approval process made? What are the decisions that go into this? This produces kind of a nice summary here. Overall, in terms of the evaluation metrics, how did our model do? Well, so-so. I mean, it did do well in terms of the actual versus the predicted for this, okay? That was pretty good. Didn't make too many mistakes here. Okay, actual was yes, predicted was no. Obviously, a couple of customers would be unhappy with that if we were to go through with that, but here it didn't do so well. in terms of, yes, it did not bad here, okay, but the type 2 error here, I mean, we've got 22 here that should have been no, but were actually predicted as yes. Okay, so that doesn't bode well. We need to go back, have a look at the model, maybe try something else, maybe have a look, see what we can achieve with that. And overall, in terms of the accuracy, 0.83, precision 0.83, recall 0.96, F1 score is 0.89. So actually not bad overall, I would say, but room for improvement. This is fairly naive, okay? So as you can see, I'm working through this fairly straightforward. I'm not doing any particular tuning or anything. I'm not going back to revisit it, but this is the first pass through the data just to see how good a model we can build. And obviously, it's an iterative process, right? You go back and take a look, see what you can improve, what you can change, and what might be better. All right, now, all of this is great. So what's my point in showing you this? My point was that we have established tools and techniques that can allow us to get great insights into the data and down to the level of a specific individual, which could be very, very important, especially for something like a loan approval. And we can actually take a look at the details and see the factors that influence that and be able to adjust as we need, or to be able to fine-tune whatever we need to do. And that's very handy. Now, working with an LLM, unfortunately, what we have at our disposal is far less useful. So in order to use that, let me just go back here and check to see if my, my environment is up and running. Let me just get back here and take a look. Our workspace seems to be fully provisioned. Everything is okay there. That seems to be running fine. Let's just go back. Okay, and you see I had some problems here a little bit earlier on. And let's try and run this and see if we can get this going. Loans DB. Okay, let me just try this. All right, so it's a slight problem with the workspace environment today, for which I apologize, but let's try and see if we can wing it here and see if we can create it from over here. Let's see if that will do the trick. It may be a connectivity issue between the notebook environment. Okay, so that seems great. It seems happy with that, using the SQL editor rather than having to do it from here. So I don't want to drop it. And I've just out of interest, let me just see. Oops, if it will let me run this. Oh, that's interesting. Right, so there's a slight problem there in terms of the driver. Let me just check here. The loans DB is selected. That's okay. Let's try again. Right, so this should not do anything because the database, okay, there we go. My apologies for that. We were having some issues a little bit earlier on. So this was working, okay. All right, but let's just keep going, okay? So the way to do it would be here, what we simply do from the notebook environment, we create the database if it doesn't exist. You saw me do that from the SQL editor, but it's not picking it up in the notebook environment for some reason, and I apologize for that. And so here, what we would do is we'd need to select this from, let's just pick this up, try and get, oops, sorry, trying to do too much one time. Let's get rid of this and try and get my arrow. So up here, okay, you can see there's a pull down. So once you've run the command for the database, you check to see the workspace is correctly selected, which it is, and that the database itself is correctly selected, which it is. So this is what the action required is just reminding us to do. I have a feeling that because of that connectivity problem, we may not be able to connect, but we will try. And let's just see if we can store this, if this will work. Okay, that seems to have worked. So whatever the problem was, it seems to be a little bit intermittent. So all I'm simply doing is taking the train and test data, storing it into the database system. Here, I'll just quickly get my OpenAI key. Bear with me, and let me just show you this last bit, and then we'll wrap up there. Okay. There we go. Let me just execute this and try this. There we go. Okay, couple of imports. LangChain, and this is the bit of code that does the magic. Okay, so this is using the SQL agent. I've set the verbose mode to true. So essentially, what I'm going to ask the database system is here. I've said, use the loans train table to build a loan approval model. The loan status column is either Y for approved or N for denied. Use your model to determine if the following loan would be approved. And I provided exactly the same information that I did earlier for the logistic regression and the BERT that we were using, okay? And we know that this is actually approved, okay? So let's try this and see what the LLM makes of this through LangChain. So here, because I've set verbose mode to true, it's showing me it's kind of working out. How did it arrive at the decision? So it's come up with the conclusion here that this loan is approved, which is actually correct, okay, if we compare it back. Now, if we look back to see what did it actually use, it only used 3 rows from the trains table to arrive at this conclusion. Amazing. But the rest of it is very opaque. I have no idea, what else it is used in order to determine this. Let me try something else here, okay? The second example, this one is, again, picking something, and this is in the test table. So I'm specific about what I'm asking it to look at, the loans train table, rather than the database overall. Otherwise, it might cheat and go away and find the answer. So I'm being very specific here. So again, it shows you it's working out. It's rather opaque again. It says, I've looked at these 3 tables and I've come to the decision that this person is denied, which is actually correct. Okay, so that person did not get a loan. All right, so let's go back to the slides here, okay, and just summarize what we've seen. So these are the sort of key technologies: bit of scikit-learn, bit of logistic regression, but not so useful. Chat and Lime, yes, I like them a lot. Very helpful in terms of focusing on the specifics of an individual down to that level. The LangChain SQL agent, awesome in terms of the result, doesn't have to do very much. Few lines of code will deliver the results, but it's opaque. I have no idea what it's doing behind the scenes. I cannot, obviously it's making some decision and it's telling me to some level what it's looking at to arrive at that decision. But beyond that, I don't know. There may be some bias that's part of that. That's hard to guess. So we looked at some loan data. We looked at the loan prediction model, using logistic regression, did a bit of text generation with BERT. Like I said, I didn't find it very useful. Chat and Lime, awesome tools, very, very useful. I'd use them again in the future. The LangChain SQL agent is great in terms of utilizing the power of the LLM to help us make a decision, but I don't know how that decision has been arrived at in detail. Probably what I do is I use this to augment the existing approaches that I already have, rather than relying upon just that technology. Okay, here we go. Just to summarize, any sufficiently advanced technology is indistinguishable from magic. Arthur C. Clarke, one of my favorite sci-fi authors, passed away some years ago, but I think he hit it spot on. So it seems like magic. And would I use it for a real loans approval system, an LLM? At this stage, probably not, simply because I don't know enough about how it's coming up with these decisions. Unless and until I have more insights into this, all those kind of issues that we talked about in the disclaimer, the bias and the other factors that it may take into account, which may not be correct, we need to be very careful. And that's the final thought, if I can leave you with that. Over to you again, Matt.
Awesome. We have way more questions than we could ever answer in a few minutes, but keep the questions coming. We will try to answer everything via email, even if we don't get to it today. I'm going to pose you a couple questions, Akmal, and then we will do the AirPods winner. We'll announce that in just a minute here. So the first question here, there was multiple questions, Akmal, that kind of got at the use of traditional machine learning versus semantic search. And I know that question or that issue has come up for you in lots of previous webinars. So I wonder if you could just talk a little bit about where you found value in machine learning versus semantic search versus everything together.
That great question. So I think my overall impression, having worked with this for a little while, I mean, I'm by no means an expert. I would consider myself a novice and a user and a dabbler. But what I've found is that a lot of the existing machine learning tools and techniques are well established, tried and tested, lots of skilled people available. If you want a data scientist that knows how to use scikit-learn, you can find one today. Very easy. And so those techniques, I think there's a great body of knowledge, great examples, plenty of stuff that we can see how it actually works. That is very, very useful. The LLMs, the semantic search, it's relatively new in the sense that it's recent. It's in the recent past. Okay, it hasn't been around for 30 or 40 or 50 years. Let me put it that way. But I think it's exciting in its potential. It offers great hope and scope, I think, something that can augment what we already do. But I wouldn't rely upon it per se, certainly not for this type of application right now. In the future, it may be better. It may be able to share its insights with you, and you can see in detail how it's arriving at a decision much more. And until I think we have that, it would be something that I would be very cautious about.
Good stuff. Here's another question that said, how do we take care of cases where we need more information from our users or our customers? And I know, you and I have talked with Eric about doing a future session with dynamic vector stores and like a chat bot or something that refreshes the vectors. But I wonder if you could talk about that a little bit.
Yeah, I think if I take the quick example of just say loan approval, typically then let's say you go to a bank, you want to get some money from them, you fill in a form. If that form is incomplete, they're going to tell you, sorry, we can't make a decision. You haven't given us all the information that we need. Until the form is complete, that process is not going to complete. And then typically a lot of this is done online now, right? And there is a step, so you work through a form step by step, and it will not allow you to sort of submit it until all the pieces of the various fields have been filled into some degree. And then the bank, at the end of the day, it may be some automated process. Typically at the beginning there is, but then there's always some human element to that. And I think that's still very important. I think more broadly, in terms of the stuff that we do, absolutely. There are things that are probably bits of information that are missing. We may be able to add those dynamically. Certainly with things like vector databases and semantics, it's super easy to do. Basically, you just create the vectors, and that can be done on the fly. As you know, we've shown this and demonstrated this in many presentations that we've done over the past sort of 6 months or so. And that is a way that we can add the missing bits of the information. We simply can ask the question and get the answer back.
Great. A lot of people asking about stuff like MySQL connectors, also about Kafka, and generally kind of like the value proposition for single store. Wonder if you could talk about that just a little bit in terms of, ways to get data in and why would people use single store?
Yeah. Okay. So the two cool technologies that I've worked with, as I said before, that I really like was the single store Spark connector, which is awesome, and the Kafka support, which we actually have built in. I mean, it's pipelines, okay? So we can do that directly from within the database system itself, stream the data in. There is a separate Kafka connector as well. So if you go to the Confluent website, for example, you can search and find the connector that we actually provide through that environment too. I think it all depends on what sort of data you're dealing with. So as you know, the past 2 webinars that I've done, we've dealt with streaming data that's being loaded into single store using pipelines. And that's a great way to be able to get lots of data in. And particularly if you've got a large workspace environment, large cluster of machines, it can do it in parallel. So it can ingest vast quantities of data at scale, at speed, and that's going to be awesome. Smaller scale, I use MySQL as well. I use the MySQL client, small bits of data. You can just load it in from a CSV file, for example. That's a great way just to load a small quantity of data to work with. And for demos and things, I mean, I find that really, really useful.
Awesome. All right, one last quick announcement before I announce the AirPods winner. Again, today, only single source AI in San Francisco on October-25, and you'll get your $25 ticket. All right, to the announcement, today's AirPods winner goes to Zach Protogeros, who is a senior director of analytics at First Tech Credit Union. I can see why you were interested in this topic, Zach. Congratulations. Thanks for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day for anyone who has tried this out. We're also going to send out Akmal's tutorial. If you want to see this code directly, keep an eye on your email for that. We will also send out a recording of this session so you can play that back and see it in more detail. Thank you so much to Akmal for an awesome session today, and thank you to our audience, everyone, for joining us. Have a great rest of your day. Bye-bye.